And then we started with these exercises. Have you already done these exercises now? Who has done them? Not everybody. Okay, but many. Yeah. And then if you already did them, then you just can progress. The next thing to do is then these exercises here. And then I will, after this topic, I will also put the solutions here to be shown, by not immediately, because that's a bit like maybe lame. If you can, of course, you can also ask the ChatGPT, yeah? Yeah, and also because here in the additional materials, there could be some like videos. If you find some good ones of the topics, then you could suggest to me and I could also put them here. But I just thought it's a bit silly to put something in English because there's so many. So I don't know what, who prefers what and what is the best. So for sure, if you put this topic on the YouTube, for example, you'll find really a lot of videos. And I don't know if you nowadays use the videos anymore or just the ChatGPT. It's also different from the previous years. I don't know which one is more like preferable to explain if you need to ask. Do you Google a video?
Yeah, well, I sent the book.
Okay.
Then AI was when the book.
Yes. Yes. So we could start now, like I thought the last time that there was this thing that I did, and then I said that I'll explain it through. And if you need to explain the nation, you should listen to it. And if you don't, you should just continue with the exercises. These were the sort of the ones that you get points. Hello. And then the ones that you need to train, the bit more like maybe challenging exercises that we do then in the written exam as well. And then also, I will put when we progress, and then here is the fifth topic, the proportion and percentage. Most probably there I will put a couple of tests more, and then the points will be given in a bit different manner. So because there was, of all these little exams or tests, you get this like 1 point maximum, yeah. And here's only one of the percentage, which is very simple, but most probably I will put here maybe two more of a bit more challenging ones, because I have that kind of exercises from this project as well. So why not? It would be just the difference of 2 points. So if somebody doesn't want to do them, that's fine as well. But then if you want to, then because I think they are quite good. This is not like this. These exercises on this course are that challenging anyway. So why not to put there a little bit something a bit more like maybe you have to think a bit more. But they are not there yet. So there's next week I put them there, or maybe even today. Okay, and we were here. And now I have to, forgot something. I forgot to restart. I hope that this will work. This might, if it doesn't, okay, see. Oh, no, like this. Mhm. No. I have to diminish. No, this is no. This. This could be a little bit bigger. Even more. Okay, so that was the example. And this was from those exercises that you do with the stack. And you had to solve this kind of equation. So I will do this as a written example now. What happened here? And the ones of you that already know, you can then just continue with the material. So, is this a good color? That's not the best color. This. So I had here something like this. And this was, the basic things that we have already rehearsed also. So how to remove the brackets, all these things, and just the very basics that we started with. Okay, so it looks like this here. Of course, when you write something like this, you would most probably write it like this. You remove this. You don't keep this multiplication sign here. Yes. 7 times t is 7t. Yes. So I'll write it once more without those. And of course, like this, the language of stack, and then it looks a little bit different, but in stack you have to write those multiplication signs. So what this means now is, because here is this equal sign. Then please correct my English if I'm doing mistakes. Okay. It means, of course, that these it's the same on the both sides. Yes. So if it would be scale, it would be like this, or if it's some kind of a number. Let's say this is totally 10. So then this is totally 10 as well. 10 is 10, or 8 is 8, or whatever. But we don't know what is the actual number here. There's just many numbers and some one letter, because we don't know how much is this letter here. Yes. So that's what we have to solve now. And we just use the maths, the language of maths, how it goes. So first remove the brackets. So I do this like thoroughly. Of course, now when you have in front of the brackets here the plus sign, so these signs inside the brackets are the same as they were. If it would be minus, they would be changed. Yes. So it would change, but now when it's plus, I just remove the brackets. It looks the same. Yes. Okay, and now it still looks also the same as in stack, except for the multiplication sign. So now what I need is I want to have the solution like it looks like in there in the stack. It has to look in the end always like this. So this letter that I'm solving has to be alone on the left side and everything else on the right side. There might be something more as well if there would be some other letters, for example. If it would be a physics equation with some other letters there that I can then give values. Yes, but now there's only one number. So it could look a lot more complicated. This is just simple with numbers. Okay. So how do I start? I can, for example, here calculate these together, or then I can just start putting these number and multiplied t multiplied with the number on the same side and only the numbers on the same side. So the ones with the t on the left and the ones with the only number on the right. But for example, I could calculate first here a bit. So if there's 7t minus 8t, maybe there would be a minus t, yeah? Yes. Oops, that was a big minus. Does it look like a minus? And then if there's minus 4 and 5, it would be plus 1. Yes, of course, like this. I would have made this side now a bit better. Okay, I won't. That's a minus. And the other side is still the same. These ones I can't do anything with now because the other one has t and the other one no. So I can't, of course, like simplify that. And then, and this looks a bit different what was here, does it? So here it was done the way that all the terms with the t were moved to the left side and all the terms, well, there was something was calculated. So those ones were calculated together, but otherwise it was done a bit different way. But you can pick and choose yourself. So now what is left here is that we have to have the terms with the t on here on the left side and the numbers on the right side. So now I will need to move this to this side. There's minus t and it changed the number. Change the sign. This is a plus sign here. The plus sign, of course, you won't write. Yes, but you know that it's positive because there's no minus sign. Now it's a minus sign there. I leave this other one still here. So there would still be the plus 1 and here would be minus 3. So I do this one step at a time. So what I actually did was that I what did I do? Please say it in English.
When you touch them.
Yes. Subtracted.
Yeah.
I subtracted. Yes, that's it. This from this term from the both sides. So this is how you write it, but you don't necessarily have to do this. Of course, it's some kind of a notification for you. You know what you did, but it's not like I will take any points out of you on the exam, for example, if you didn't do it. But this is what I did now here. So I subtracted the 2t from both sides. Yes. So from this side, it disappeared because 2t minus 2t is, well, 0. And to here, it appeared. Yes? And of course, this is what always happens, you know, when I process this kind of equations, because it has to be always the same number, basically, on the both sides. So if I would only take it out from the other side, then it wouldn't be the same anymore, yeah? Okay. So this happened, and now I can continue. So what I need still, I need this away from here, yeah? So then I mark here that I'm taking it away, -1, yeah? And then I can also calculate these together. So there would be -3t, and here would be -3 minus 1. So I subtracted 1 from both sides. So from this side, it disappeared, and to this side, it appeared, yeah. So that's no magic, and for sure, for many of you, this is already quite self-evident. But this is something that is then when you calculate on paper, this kind of things, it's really easy to make mistakes anyway. So you just have to think this through slowly, like, or peacefully, basically. It doesn't have to happen slowly, but peacefully, because it's just really easy to make mistakes with this, which is surprising. Also, I can easily make mistakes with this if I don't think what I did. Okay. And now then I wanted to have the t alone. So either I can divide with -3, like, which I will, okay, let's do it that way. Or I can think that I first divided with -1 and I already get a positive sign here. Like this is, you know, let's divide with -3. Because that is what I want away, yes. So I want to have the t alone. So I need the -3 away. If it's multiplying the t, of course, I have to divide it away, yes? So what happens here is, I could have done this even more thoroughly. It's like, here is the -3t, and then when I divide, of course, the -3 comes also below here. -3. So what happens here is, of course, that these cancel and these cancel, yeah? The t is alone. And here, if you divide minus with minus, you have the 4/3. Does this look clear to you? Yes. So this is something that you would need to have the nerves to do for every calculation, just peacefully, because many times then, you know, you calculate just these simple ones. Also in physics. But I don't know how much you calculate by hand in physics. Not that much, yeah, because you're with Jaakko and you do more like practical exercises and you write the results in Excel, yes? So these courses now are pretty different style from each other. And we have also like more like sort of, how would you say, maybe old-fashioned physics teachers with whom you do a lot of things like this. But at least with me, you get to practice this. Because then maybe you think that this is silly, but the people who have been working in the, for example, as engineers in the industry, and you have a process that you control. And then if it fails, if something's wrong, they say you always calculate by hand. You take the paper and you start calculating what went wrong. It's not like you check the numbers, there are your programs, there's something happening. You need to know. You need to do this. Basically, there's just different variables. You get some weird number there. You know what this letter means. What is that in the process? then you have some other variables there as well. So this is something that every engineer needs to have the how do you say, the patience to do. To calculate simple things by hand and to know how it works. Okay, so maybe now, if you still didn't do this test of these, you can continue with that. And then we can soon continue with the other exercises and a little bit more theory.
Hello.
Oh yeah, thank you for the, I have to go and press something in the back. Yes. So somebody else is already here and I have to go there. Okay, there's already 24. Okay, so the ones who have now enrolled on the course, can you now see the course?
Ma'am, actually the course is not showing on my portal.
Yeah, same here. I have like basically enrolled in Peppy, but it's not
Wait.
saving on.
I have to put somehow I can't hear you at all.
Ma'am, actually we are saying that we are not enrolled. It's not showing in our Moodle.
Could you please write, because I don't know why I can't hear anymore. I have the, maybe I can put it some other.
Would you please
Let's-
explain her?
What is that? Try to say something now.
Hello, can you hear us now?
No, I can't hear anything. How about now? Nothing. So something.
Can you hear us now?
Could you please write here if you have something, because for some reason this is really low the sound, although I have this on full speakers. Can I somehow just in here?
Okay, let us write.
Maybe. Okay, so if you have something, please write here. I hope you can access the course. Can you access the course? Yeah. Yes, good. Okay. It's good if you can hear each other. For some reason, for me, that this is like really It also tells me that the sound is really low. I'm gonna do something now so that I get this on the other. Yes. Oh, that's this is now I'm able to take this on the other. Okay, so then if I enroll you and you can't access anyway, because it should go through the Peppi. If you enroll to the Peppi, then maybe you will be there twice, or maybe that's not a problem. So I just have to put your names. I'll put you there, and you might then, if it starts working, then you'll be there twice. I'll put this away here now and do it there. Mhm. Mhm. Okay, I can't find you here. Maybe you are already there. Let's check. Yeah, you are actually on the course. It looks like on the in the course Moodle. Hmm. Yes. Uh, yep. Yes, yes. You are. So maybe you just have the difficulties finding it from the model. I'll put it to here. It's just so you can find it with the with this. You just have to look. Oh, yeah. So what I meant, what we are sort of practicing for is something like this, for example. But here's already some kind of second degree term, but whatever. So you have some variables in in physics, you have these kind of equations. You have some variables. So to certain of them, you have a value. And one of them you're maybe controlling. And then when you are resolving it, you have some kind of a process. And then if something goes wrong there, you need to know what kind of law it applies to this process. Of course, then you just start calculating by hand what went wrong. Yeah. So this is what we are trying to learn, just the basic tools to do it then later on. That would be, for example, one equation that you could have. But of course, they might be a lot more complex. You have certain things that you adjust there, and then those dependencies of.
For that, this was supposed to go into linear equation. There you go.
Yes.
How would you put that into the line form?
How does this look like? You mean?
Yeah, well, that's just but when x equal to ms plus u, how would you put that? That's the slope.
Which equation?
It's just the line one,
Just the line one.
Yeah. So I have the PowerPoint.
The PowerPoint.
Yeah.
You're talking about this presentation.
Yeah.
Okay.
That what you calculated on the page is the slope of it. Is that right?
Wait. So I have so many things here. The PowerPoint. I need to open the PowerPoint now. Yes, because it's here. Oh, this one.
Yeah.
Yes. Let's have it like this, because otherwise it will go somewhere else. What if I go through this now?
Yeah.
Okay, cool. So linear functions then. We had those equations, you solve. What it means is that you have a linear function. Why is it linear? Linear means that it's like a straight line. And then it's not a curve or something. Then you need to put there the powers to the letters. Yes. If you have powers on the letters, then you get already something as well. I'll just go through this first. Okay. So it means this. For example, there is an equation of one straight line. So fx is minus 2x minus 4. It's a mathematical function that creates a straight line when graphed on a coordinate plane. And it describes a constant rate of change between two variables, typically x, which is independent, and fx, which is dependent. So you give some values to the x, and then the value of the fx, of course, follows from it. So here you can adjust some number in this equation, and then you calculate the number of this with it, yes. And then when you put it here on the coordinate plane, here you have the value of fx, and here you have the value of x. And fx is actually the y coordinate, yeah. So it means the same as the y coordinate in the graph. And there's a general form of linear function. So it's exactly the same as m is the slope. So it describes how steep is the line here. For example, here it's minus x. So if it's minus, it goes downwards. And this is a bit like, this is from GeoGebra. It's not like maybe the best graph, but yeah, so it's okay, but let's just progress. M is the slope, B is the, yeah, y-intercept. So the B here, which is here 3, you can see it's where the line crosses the y-axis. So this would be the number 3 on the y-axis. And x is the input variable that you can vary. And fx is the output value. There is also this kind of interactive thing. We can look at this, but let's look at maybe this first. So for example, here the slope 2, and it cuts the y-axis in -3. Well, and what does mean that it's the slope 2? Here you can see it clearly. For every 1 unit of x, it increases 2 of y. So this is basically how it goes. So the slope you calculate with the points. So you have here on top of the line, this is like a fraction. You have the y2, so the coordinate, y coordinate of the point 2 minus the y coordinate of the point 1. And under the line, the x coordinates. So for example, for this, you would be here at 6. Here, this is the y, yeah. You would put there 6. And this is the point 2. So you came from the point 1 to the point 2. And you started from the y coordinate 2. So from 6, you diminish the 2, like in the equation here. We still look at the equation, how it's in the technical formulas next. And then under the line, you have the x. So in this point 2, you have the x coordinate 3, and the point 1, you have the x coordinate 1. Yeah. So this is how you get the slope. So for example, here it would be the 2. So for every 1, so when the line progresses for every 1 x, it progresses to y. So 1 on the horizontally and 2 vertically. Yes. Point slope form. Okay, so that is the normal way to write the line was this. So fx was the y coordinate. Here is the slope. And if you know only a point, 1 point of the this line, you can put it here. So you know that the x coordinate and the y coordinate on one point of the line. So if you know the slope and one point of the line, you can form the equation of the this slope. So for example, a line passes through point 2 and 5 and has slope of 3, and you just put them into the equation and you get the slope intercept form. Here is the technical formulas is right. So this page on technical formulas, the page 28, it has a lot of information. So in maths, the technical formulas is not really as informative as in physics. In physics, you can see all the equations really clearly and everything really clearly explained. And in math, it's a bit more like it looks a bit unclear maybe. Do you think this looks a bit unclear? How can you find anything from this? Or do you think that it looks clear?
I recognize.
Yeah, so I pointed them out with yellow color, the equations that you have some use of for this subject. Then it also talks about some like vector presentations for the these lines, but we are not handling vectors here. Do you do like these kind of vectors in the physics now? Joo, meillä ei esimerkiksi, we don't have in my physics, that is the physics for the department of, for example, construction engineers. They don't really do vectors at all. They just do like basically the lengths of the arrows. Let's put it this way. So because they are not like, you don't need that kind of thought maybe there. Because you can think it, many things in maths, you can think of many different ways. If you go to theoretical, it just mixes the students up, yeah? So keep it simple. Here is the equation of a straight line in the coordinate form. So if you know here the k is the slope. And why is it k? I don't even know from which word it comes. In Finland, it's kulmakerroin. But why would it be in a technical formulas in English as a k? I don't know if it's used as a k in the English expression. Okay. In Finland, it's always k. So that's the slope. How steep is the slope, basically? And if it goes downwards or upwards, if there's a minus sign in front, then it goes downwards. And if no, then it goes upwards. And then you can put here this one coordinate that you know, and you get the equation for this slope, for this line. And here you can still see how this k, which is the slope, how it's calculated. So here's the coordinate form, y2 minus y1 and x2 minus x1. This what was in the example on those slides, yes?
Yeah.
So that this is how this k is calculated. And here is the solved form. So this is how it usually looks like. Y is k, which was the slope times x plus b, and b is the intersection point of the line with the y-axis. This is like that. It's not always that great English, but I got it out. Yes. Yes, of course it would be better if somebody native speaker would be doing this, but we don't have such working here now. Okay. So then an example calculating linear function from 2 points. You can calculate first the slope, and then you just put into this equation point slope form the
1 point here. And you just calculate it through and you get to the equation of this line. Yes, it makes sense. Finding more points of the line. So pick any value for x and put it into the equation, and you got the y value there. Yes. So you can calculate any points. For example, here you would have put the -3 into this equation, and you would have got 0 there as a result. So it's -3, 0, and so on. If you would have put 0 there as an x, of course you got 6. Yes. And then you can draw the line. And then there were some examples still. Identify the slope and y-intercept of the function, this kind of a function. So what is the slope here? And what is the y-intercept?
-4.
Yeah, -4. Okay. Graph this function and labels blah. So this you can do, for example, with the GeoGebra, yeah? Interpret the linear equation. What does the slope present? So what does it mean that it says 0.5 here? What does it mean? Yeah, half. Yes. So when you progress one x, you progress only half upwards. Yeah. Yeah. Okay. Determine the value. So for the x, if you have the x coordinate 2, what is the y coordinate? So you just put the 2 in here. Yes. So it would be -2, -3, it would be -5. Yeah. Okay. And here are the same things. Same things said. Well, this is said, it's not drawn, but it could be better with the picture. Oh, yeah. What we didn't say y-intercept is, of course, 2 here as well. Just like that. That's it. So now maybe we can progress to the I have somewhere this. Yeah, and here you can try the slope. I think this was some kind of GeoGebra applet as well, where you can try the slope value. Oh, but it doesn't work. Here were many ways of trying this. Like this. How much does it rise when and this is now 5 already if you put it to. Oops. Let's put it to go 1 minus 1. Yeah. So if you progress 1 and here you rise 8, then of course the slope is 8 divided by 1, which is 8. Yeah. This is really simple. Who thinks this is really simple? Who thinks that this is difficult? Okay, so if it's difficult, then just you have to practice. Yes, and here should be plenty of exercises that you have that you can practice with. You can even go through these here. Go through, test if you know which slope you're getting. Maybe it doesn't make any sense that I do this here. You can try them yourself. Yes. There's a lot of these exercises already here. For some reason, this opens to a different page, so now I have to go back. And then there's also a lot of exercises that we can do on paper. So here's again solve for x. So this is more like this. What was it? Like a bit like the sum expressions that we did. But now you just have to always come to the solution to x. You don't have to do all of these if you don't find them necessary for you to practice. But if you do, then please do them. Then you can draw the slopes, find equations for the slopes, find an equation for a line that goes through points, just like on the examples there. Calculate some values for this kind of a curve. This is not, is this a linear function here? No. You can try this with your, draw this with GeoGebra. It's a 3rd-degree curve. And then we can, of course, call this 1st-degree polynomial function. It's exactly the same thing. It's just a different name. And a little bit more exercises for this. So it sounds a bit more official, maybe. Yeah. 1st-degree polynomial function. Yes. But we need to know these terms, what they mean. We are learning the language of maths. And then there are still a couple of written exercises here. And something even that would maybe have something to do with physics. It could have something a bit more difficult as well, but maybe later we take something more difficult from physics. So practice the way that you feel that is practical for you. Yes. And I'll do something here on the same time as well. And you can also ask. I will still show something here now, something different because somebody's asking. Okay, so about the videos, there's only one video now so far, and it's the recording of this week. And you can find it under the sum expressions. And it's here because last week when I recorded, I couldn't open those videos. I recorded them to the cloud. And that was obviously a wrong place. So I'm recording them on my own computer and I'm able to open them. So here's the lesson, the first lesson of this week. And now this lesson is being recorded and then I'll put it later. And because we were handling merely the sum expressions, you can find it here. And then this recording will go here under the heading classes and recordings. But sorry about the impossibility finding those previous ones. I will still write this. Okay, so for these exercises, maybe this first one, it looks really similar as the stack ones. For sure, you get a lot of practice with this now. And then the next one, maybe some of this, I'll just do a couple of these here. But you can also continue working on your and then just ask if you need to. Whatever is the best for you. Do you have something that you would like to ask of now? No. So just keep on working. I do a couple of things here, and then maybe if I feel like I need to explain something, then I say yes. Okay. So this is what it actually means, yeah. It's 4/3 of x. You can write these equations like also in the technical formulas book. The equations can be written in many ways. Okay, so now I know that here is an x. Here's 1/6, and here is 4/3 of x on the other side. So I want to have all the terms with x on this side and everything else on this side, yes. So I'll move this term with the x first. And of course, I can also do the same time the other thing. I can write it like this as well. So if I do this both. So here I would get this 4/3 of x. It went away from that side, and to this side I get the -1/6. This is exactly as simple as before. So here, of course, like I can still write here, I have here 4/3 of x. I have, of course, 3/3 of x here, which is the whole x. Yes. So then I get, if I get here -1/3 of x. Yeah.
You multiply. Taking one.
You mean this?
No, there's no.
This.
Yeah.
What happened here?
Oh, I say, sorry, I'm thinking more.
Yeah. So this is the one way of thinking it. For me, it now looks more clear. So I see this kind of equation. There's 4x here, and there's 3, and I start to think, okay, whatever, I have to get only x, and will I start multiplying with 3? This is also one possibility. But for me, I went this way. I could do the other way of thinking of this. So because with all of these, then when you start making the solutions, and especially with something more complicated, all of your solution is like your own, and you think it's your own way. So I could think it like this here. I have this equation, but now it's a bit smaller. and I see like, oh, there's x and 3 under. I want to get the 3 away. So I'll multiply with 3. This might be even more simple this way. So I multiply everything. Yes. And this is what you wanted to do as well, didn't you? So I multiply this. Then I have to multiply this, obviously. Everything's been multiplied. Also this side I multiply because this is why I'm doing it. So I get only 4x here. This looks nicer now. And then what I have to do again is I won't write now because it doesn't fit there. But this one goes to the other side. Minus 4x. Yes. So I diminish the 4x. I subtracted the 4x. And then I have to subtract, and this is 3/6 is it's a half, isn't it?
Yeah.
So I get minus half on this side. And then if I progress, I get here minus x. Here is a minus half. Now I should get the same from the both. It's really easy to make mistakes. So the answer would be half, yeah? Okay, so I'll continue my other quest. My other quest went this way. I had minus 1/6 here. And then I just have to have x here alone. So I'll write here because it fits that I multiply it with minus 3, yeah. If I multiply it with minus 3, then I get this cancelled. There's a positive x, yes? There's a positive x, and here the minus 3. So I'll still put it here somehow. Minus 3, I'm multiplying this minus 1/6 with it. So this is, of course, also half, yeah? Does it look yeah, thanks for asking. It's nice if somebody asks something. But this is like you think about these things and then you see your own way of doing it, yes? It doesn't have to be the way that I do it. Who thinks that this is simple?
Yeah.
Who thinks that this is difficult? Or like difficult to follow what happened here? How about the backline there? How do you feel about the maths course? It's easy. Okay, cool. Yes. You've been doing similar things like previously and not quite recently. Yes. Okay, good. So then you can just continue. You can do what you need to do. But then I will put a couple of more tests for the percentage calculations that are a little bit more complicated. So there will be a little bit of change of calculating the points then, but just like 2 points. It doesn't do much, you know, maybe 20 more exercises or something done by Stack. Yeah, and then of course in the last part also, like this is not like the course is completely ready, because in the last part where you have to form your own equations from something that's written, there isn't even the test yet, and so there will be also more material later. I just didn't put it there yet. I tried to do this kind of a quiz and then like something went wrong and then I have to try again when I have time. Yes, but we are not there yet. So it's even if you would complete the course now, you know, and do everything, just like do it away, there might still appear something later. Yes. So, but not immediately.
Yeah. Wait, on the number 5.
Number 5.
Yeah, on the paper, the questions.
The questions, yes, here.
Yeah.
Does the fry? Okay, cool. Yes. Find the equation for the slopes from the figures. There. Okay, so you see there a slope, and you know that how would you start to progress with this? You of course take your technical formulas because it's your best friend. Or maybe the ChatGPT, but at least it's for the written exam. And then you know that you need to get something like this. For example, a solved form. So I know I need something, equation for a slope. I need this. For a slope. And now this is, I know that this is a straight line. Straight line, and then I go to technical formulas. TF. This is TF in English. And I'm on the page 28. So then I can find how the equation basically looks like here with all these equations. Since this is the most simple form for the what I need now. So I take the equation, I found it from technical formulas. I need something that looks like this. Now, from the technical formulas, I can already also see that the B there is the y-intercept. So then I can go to, let's go to the first exercise here, and I can see the y-intercept there. What is that? I'll write it first here. So the B I want. I'll write it here like this. I want this equation now. What is the B? In this figure? 0. Yes. I'll write it there. I don't, of course, have to write it. So then I need to know this K. Yes, I know that I will write here X, and here I still write Y, but I now only thing that I need is this K. How do I get the K from this figure? Here. What do I know from the K? K is the Y, wasn't it the Y2 minus Y1? It looks like this here. And this is also in the from the technical formulas. I write this the way the technical formulas say it because this is something that you have always with you. So you should somehow learn it from here. So you need the you know, basically like the, do you call it the delta, for example, in physics, the change, the delta y divided by delta x or something. So what is the K here? If we would take, for example, these points, we can calculate it, or we can just see it straight from there as well. But I'll calculate it here. So I have my first point would be the 0, 0, 0 and 0. And my second point would be 1 and 2. So here is the y, 2, and here is the x, which is the 1. Yes. Does this make sense to you? Yes. So what do I get? Yeah, 2 over 1, which is 2. Yeah. Yeah, this is something that you'll see many times in maths. You can divide or multiply anything with 1. But it doesn't change. Sometimes you use this as some kind of a mathematical tool, if you want to. Okay, so now I just write what I got. Here, the 2. So it's actually y is 2x. Because, of course, I don't have to write the 0 there, do I? And you can always ask if you need to ask something. And also if you're on a different opinion. That would be also fun. Yeah, if you would think that this is not done like this. Yeah. That sometimes happens as well. And sometimes I might be wrong as well. Can a teacher ever be wrong? What do you think about that? Has that happened to you that your teacher was wrong? To who did that happen? Ever, that your teacher was wrong? Yeah, of course you have to say if I'm wrong. Then everybody else get this same information if it was a false information that I'm giving.
I don't know now. The maths that they're wrong.
Yeah, but then it doesn't matter, because then if I finally wouldn't be wrong, but you would think, then most probably what you think is somebody else would think as well. So then you help everybody if you say it. Yes. So only for one of you it happened that sometime your teacher was wrong. I think maybe that's everybody makes mistakes. Yes, I think most probably that has happened to everybody. Maybe you just didn't realize. Okay, so we maybe do one more, or for here in Finland, students are very vocal if they know something about something. So they tell that, look, it's not like this. Especially when you go to engineering and the teacher has some old information of some process. It says, no, I worked there. It goes like this. Sorry. Yeah, this happens. And then that's really good for the teacher as well if you tell it. It's like, okay, yes, that makes sense. Like, okay, I'll find out about it. Like this has already changed since I was working there. Mm. Hmm. So if I look at one more, I get the b there. It seems to be -1 from the picture, yes. Mm. And how about the slope? What is the slope? There has to be minus sign because it goes downwards, yeah? And how much does it go downwards? So the x progress is 1. And how much does the y go? Y change when the x
Almost.
3, yes, -3. This is this simple. Yeah. Okay, the last one. Still, then you can go to eat. Who is hungry? Okay, so again, I know that I need this. I'll just write it first here, and then I start picking the information. So these ones will always be, that will always be. And then how about now for the y-intercept? What is it? In the C.
No, but I get it.
Mhm. Then we are going upward, so it must be plus. And how much? This is not as simple as you can't really see for 1 how much it is. It's, less than 1. So you have to look for 3, for the ones that you see. You can see the change there. What is the change? So it was the K was, you can write it with the delta as well. Is this delta sign familiar to you? Yeah, so the delta for y was
Three.
upwards. And for x on the same time, 3. Yes. Yes. Okay. Should we go to have lunch? Why not? Do you have something starting past in an hour?
It's only for the native Finnish speakers.
Aha.
Joo, siis meillä on esimerkiksi äidinkielen kurssi.
Oh yeah. You don't have anything anymore today? No. Okay. Well, at least you have, I don't know. You have a sunny day. If you're able to go outdoors, or if you have to go to work, or I don't know. Thanks.